Hello everybody and welcome. This is the Egyptian game dev Mo. Today we're going to talk about the timeline node in Unreal Engine. For those who don't know it, it's a specific node used to make things change over time. It basically outputs a variable that has a changing value, and we plug this variable into another node to give us the animation we want. We will start with how the timeline node works in practice, then we will go over all of its properties, which are essential and some of them are not mentioned in the majority of tutorials for some reason. This is the first of two videos as we will cover the different variable types a timeline node can output in the next one. So if this is what you're here for, take a look in the description to see if it's already out. By the end of this mini series, you will be able to use a timeline node to do stuff ranging from opening a door or moving an elevator to changing an object color over time, or even make a light flicker by changing its intensity over time, and many more. As once you fully understand it, you can get creative and do anything you like. I included timestamps in the description to allow you to skip to the properties part, but if you want to see how a timeline node works in practice, then I recommend you stick around. So without further ado, let's jump in. Here is a little example of what you can do with a timeline node. I have this actor here which I already created. I will drop that into the scene. If I hit simulate, you can see that it moves up. And this is just a cube, but you can apply the same principle to an elevator, for example. I coded this cube actor to make it start moving immediately when the game starts. But for an elevator, you may want to make it only move when the player is inside of it and he presses the action key. Now let's take a look inside. Let's say I want to move this cube on the z-axis from 0 to 200. So it would be right about here. And I wanted this animation to happen over 2 seconds. What I will need is after 0.1 of a second, I will set the value to 10. And after 0.2 of a second, I will set it to 20. And so on until I reach 2 seconds and I set it to 200. This is exactly how a timeline node works. But instead of setting the value once every 0.1 of a second, it will set it once every frame. And it will not set it to increments of 10 like we did, but don't worry about that. Just tell it you want the animation to finish in 2 seconds, and it will do the math. If we jump here to the event graph, you can see that I set this timeline node to play on begin play. And all it's doing is drive the location of that cube. The set relative location node is setting the cube location to the vector value we feed it using this vector track, which is essentially a vector variable that changes in value over time. If I double click the timeline node, here is what it looks like from inside. Don't get distracted by all of this because I'm going to explain it in a minute. What I want you to know now is that this blue curve here drives the z value of the vector. It consists of only 2 keyframes. One here at the beginning. You can see that the time for this keyframe is 0 and the value is 0. And the other keyframe is at the end. It has a time of 2 seconds and the value of 200. So the value will go from 0 to 200 in 2 seconds. There is also a curve for the x value of the vector and the y value of the vector. But I didn't add any keyframes here, so their value will always be 0. If you hover anywhere over this blue curve, you can see the value at that point in time, which will have 0 for the x and 0 for the y, and have a z value corresponding to where you put your mouse. So you can see how it all works. Now let's take a look at the node's properties. It has 2 output pins and 6 input pins. First one here is play. It makes the timeline play from left to right. And stop makes it stop at the exact time you call the spin. So for example, if you call it after 1 second of playing, it will stop at the 1 second mark. And when you play again, it will continue from where you have stopped it. So if you wanted to play from start in this case, you should use play from start. And there is reverse. It's like play, but it runs from right to left. And you can reverse from wherever the timeline is at, or you can use reverse from end to reverse it from the end. It's worth mentioning that reverse from end will give us the same animation as playing from start if the first and last keyframes have the same value. Let's make a little example to demonstrate this. I will add a new keyframe. To do that, you hold the shift key, then left click. We added this highlighted keyframe. You can change its time and value from here. I will make the time 4 seconds and the value will be 0. So I want it to go from 0 to 200, then back to 0. And the length of the timeline should be 4 seconds. Right now it's 2, and that would make it only run to here. So I will change it. Now it will go all the way. Let's see how this looks. Cube goes up and down again. Now let's see how this would look when we reverse it from the end. You can see there is no difference in the motion of the cube. And that's because the first and last keyframes have the same value. So it is still going from 0 to 200 and back to 0. Now let's talk about minus values. Currently the cube moves up then down. But what if I want it to go down first? To do that we use minus values. So instead of making this 200, I will make it minus 200. And if we simulate now, you can see it goes down first, then it moves up. The remaining input pin is set new time. It's used to make the timeline jump to any second we want. Let's try and make it jump to the 2 second mark. I will type 2 here. Let's simulate. It's obvious nothing has changed. And that's because we gave it a number of seconds but we didn't call this pin. So let's call it. Now let's see what happens. It jumps to the 2 second mark where the keyframe value is minus 200. But notice the timeline itself didn't run. That's because we never told it to. So if it was initially running, it will jump and continue running. But in our case, it wasn't running, so it only jumped. On the right side here, there are 2 output pins. There is update, which we have been using all along. It fires every frame as long as the timeline is running. And there is finished. This one fires once when the timeline finishes running, regardless of the direction it runs in. So if it was running in this direction, the finished pin will fire when it reaches here. And if it was going this way, it will fire when it reaches here. And you can make it do anything you want really. So let's just print a string. It should say hello when the timeline finishes. I will simulate that in the viewport to be able to see the writing. So it goes down and up, and it says hello when the timeline finishes. Okay, enough chit-chatting about pins. Now let's see some cool options. Inside of here, there are these options. Loop will loop the timeline, obviously. It gives us a nice little symbol here. Cube goes down and up, and it will keep repeating. Notice it never says hello, as it never finishes when it's looping. There is also use last keyframe. So do you want the last keyframe to fire or not? And to understand what it does, think about it like this. If it's checked and the timeline is looping, the value will go from 0 to -1 to -2 and so on, until it reaches -1 over here. Then it will be 0, because we are using the last keyframe, then 0 again, then -1 and so on. And repeating the 0 will cause a little lag in the motion of the cube. It's a tiny lag that would mostly go unnoticed, but it will be there. So my advice is to leave this unchecked, to make it go from -1 here to this 0 right away, unless you want it to lag for some reason. But what if we aren't looping? Well, I did an experiment and found out it has no effect at all when you are not looping. But just to be on the safe side, you can check it to make sure the last keyframe will fire. Next up is autoplay. It's represented by this symbol. We use it to make the timeline play without the need for this. So if I simulate, it plays. And we have replicated. It's used for network multiplayer games or online games to help sync the timeline animation for all players. In other words, if one player sees the cube at a location, while simultaneously another player sees it at a different location, then you may want to check this box to fix the problem. And lastly, there is ignore time dilation. Let's say in some moments of your game you want everything to be moving in slow motion. So for example, set global time dilation. Let's make that 0.1. So everything will run at 10% of the speed. Let's play this. See? This would take forever. Okay. Now what if I was adventurous and I wanted the cube's motion to ignore time dilation and defy the theory of relativity? Let's check this box. Now I'm running slow, but the cube has already finished. And it works either way actually. So even if I make time faster than normal, which would be anything above 1, the player runs faster now, but the cube will keep running at its normal speed. Before we wrap things up, I gotta tell you about a hidden factor that can drastically change how your animation would look when you run it. It's called the interpolation. Interpolation controls how keyframes are connected. If we select keyframes then right-click any of them, we find these interpolation types. The main ones are auto, which I've been using, and there is linear and constant. Let's start with linear. It connects keyframes with straight lines, and you may wonder what difference would that make. It makes a big difference actually, because this way the cube will be moving at a constant speed from the beginning to the end of the line. There is no acceleration and no deceleration. It's like entering a car's driver's seat, and the moment you press the gas pedal, the car instantly runs at full speed, and it keeps running at that speed until you reach the end of the road and you press the brakes, making the car instantly stop. Also, if we add another keyframe, there will be a sudden change in value at this part. So let's see how this would look. You can see it almost looks like it's hitting something, because of the sudden change in value we have talked about, which is a result of the lack of acceleration and deceleration. So if you don't like this, you can use auto. It will start moving slowly and it picks up speed, then it slows down again before it reaches this point, and the change in value is smoothed out. Then it will move fast again at this part and slows down, and so on. This is how it looks, the way we have been doing it. There is also this weird one called constant. It will make it stay at the 0 value until it reaches this point, then it will jump suddenly to -200 and stays at it till it jumps again to 0. And this is how it looks. Some games could really use something like this. I bet most of you have seen it in a game you have played. You can also fiddle with interpolation manually. When you choose auto, there are these lines here which you can manipulate. And if you really mess things up, you can always fix it by choosing flatten. This makes all the lines horizontal again. In case you got lost like this and you can't see all of the keyframes, you can quickly see them by using these. This one will fit the zoom horizontally, and this fits it vertically so you can see the whole curve. If you made it to the end, let me know in the comments, and if you have any questions, don't hesitate to drop them below as well. Stay tuned for the next video, which will be a continuation of this one, to get the full picture about timeline nodes and be able to animate anything. This is actually the channel's first video. I will be posting weekly about everything that interests game developers. You can find out more about what you can expect to see on the channel's about section. If you wanna see more, don't forget to subscribe and hit the bell icon to get notified about future videos. Have fun with your games, and I will see you next time. Bye bye.